Space is a vast place with many mysteries in it. The trillions of planets and stars are just there in space, and humans are curious by nature and want to explore this gigantic space. We know that the leading front in space exploration is NASA, and since its establishment it has made many attempts to explore nearby stars and planets, the most prominent among them being the planet Mars. Welcome to Tech Heaven, and in this video we'll be taking a closer look at the new space robots from NASA that will leave you amazed. Robotics is something NASA is good with, as it is into building them way before anyone else started. They even came up with a functional robot in the 1970s, so what are they working on now? NASA has planned for the Artemis mission in 2022. NASA's Artemis program will lead humanity forward to the moon and prepare us for the next giant leap, the exploration of Mars. With the powerful Space Launch System rocket and Orion spacecraft nearing the end of testing and development, the agency has the foundation needed to send humans back to lunar orbit. In preparation for the safest, earliest possible lunar landing, NASA seeks to make full use of early Artemis missions through additional testing of Orion and the human landing system when possible. The first technology in the Artemis program is the Gateway. The Gateway will be an outpost orbiting the moon that provides vital support for a long-term human return to the lunar surface, as well as a staging point for a deep space exploration. It is a critical component of NASA's Artemis program. The Gateway is a vital part of NASA's deep space exploration plans, along with the Space Launch System rocket, Orion spacecraft, and human landing system that will send astronauts to the moon. Gateway is designed in such a way that it will be operated solely by robots, so we can say that Gateway itself is a robot. However, remote access features are also added to control the Gateway from the ISS. NASA has focused Gateway development on the initial critical elements required to support the landing. These elements include the power and propulsion element, the habitation and logistics outpost, and logistics capabilities. First, the power and propulsion element is a high-power 60 kW solar electric propulsion spacecraft that will provide power, high-rate communications, attitude control, and orbit transfer capabilities for the Gateway. It basically acts as the navigation and engine of the craft. The habitation and the logistics outpost will be the initial crew cabin for astronauts visiting the Gateway. Halo's primary purpose is to provide basic life support needs for the visiting astronauts after they arrive in the Orion and prepare for their trip to the lunar surface. It will provide command, control, and data handling capabilities, energy storage and power distribution, thermal control, communications and tracking capabilities, as well as environmental control and life support systems to augment the Orion spacecraft and support crew members. It also will have several docking ports for visiting vehicles and future modules, as well as space for science. All these are necessary to provide a livable environment to the crew members so they can focus on the mission. The need for deep space logistics is very crucial, and the Gateway is built in consideration for this need. As astronauts prepare for the missions to the lunar surface, they will need deliveries of critical pressurized and unpressurized cargo, science experiments, and supplies such as sample collection materials and other items. By the way, if you're watching us for the first time, make sure to hit that subscribe button and turn on notifications so you can enjoy our future videos while getting updated. Getting back to the topic. In March 2020, NASA announced SpaceX as the first US commercial provider under the Gateway Logistics Services contract to deliver cargo and other supplies to the Gateway. One logistics service delivery is anticipated for each crewed Artemis mission to the Gateway. Canada announced in February 2019 its intention to participate in the Gateway and contribute advanced external robotics. In December 2020, the Canadian Space Agency awarded a contract to MDA to build the Canadarm3 for Artemis deep space missions. Let's move on to our next robotic technology called the Canadarm3. Canadarm3 will be Canada's contribution to the US-led Gateway. This highly autonomous robotic system will use cutting-edge software to perform tasks around the moon without human intervention. The smart robotic system will include several distinct parts, which include a large 8.5-meter long arm, a smaller but more dexterous arm, and also a set of detachable tools. After the successful Canadarm2, the next generation Canadian robotic system will be designed to maintain, repair, and inspect the Gateway. The 8.5-meter long arm will be able to capture visiting vehicles and relocate Gateway modules. It's also designed to be able to help astronauts during spacewalks and ultimately enable science both in lunar orbit and on the surface of the Moon. Canadarm3 is designed to work autonomously. However, the system could also be operated by robotics flight controllers in Canada or by Gateway crew during spacewalks. Let's discuss how Canadarm3 will actually work. Canadarm3's smaller arm will be equipped to transfer mission-critical material between the interior and the exterior of the space station. The small arm will be able to help repair the larger arm in space if necessary. This means that thanks to advances in autonomy and artificial intelligence, Canadarm3 will be able to maintain itself in space, swapping out parts and keeping itself constantly ready to perform precise operations. Each end of Canadarm3's arms will be able to attach to the gateway using specially designed interfaces on the gateway's exterior. Each anchoring hand will plug into an interface that supplies power, data, and video connections. These interfaces will also allow the large and small arms to work together to accomplish tasks, and will help store tools when not in use. The target date for delivering Canadarm3 to the Gateway is 2027. However, it can be adjusted based on progress of the Gateway project. NASA is also developing cutting-edge software for the Gateway program along with the advanced robots. The Advanced Exploration System-funded Autonomous Systems and Operations project demonstrated a vehicle system management capability to the Gateway program. VSM integrates automated planning, plan execution, and fault management with flight software. VSM is able to detect faults, build plans to actively isolate initially ambiguous faults, and build plans to restore the most functional state of a vehicle system in the presence of faults, while also taking into account mission timelines and objectives. In other words, the VSM will be able to do most of the work completely by itself. NASA has developed many robots for their astronauts in the ISS, so they can perform tasks with ease. We have seen the successful work of the Robonaut series, that is the Robonaut 1 and Robonaut 2. The most advanced among these humanoid robots being the R5, aka Valkyrie. Valkyrie has had several improvements among its predecessors. Valkyrie can be configured to run from a wall or from battery power. Valkyrie's head sits atop a 3 DOF neck. Valkyrie also features fore and aft hazard cameras located on the torso. Each upper arm consists of 4 series elastic rotary actuators, and when combined with a forearm has 7 joints. The arm has a quick mechanical and electrical disconnect between the first 2 joints that allows for easy shipping and service. Valkyrie features a simplified humanoid hand with 3 fingers and a thumb. The robot's torso houses 2 series elastic rotary actuators and 2 series elastic linear actuators. Each upper leg contains 5 series elastic rotary actuators. All in all, the Valkyrie is the best and most advanced humanoid robot so far. Astro-B, which is NASA's new free-flying robotic system, will help astronauts reduce time they spend on routine duties, leaving them to focus more on the things that only humans can do. They can work autonomously or be controlled remotely by astronauts, flight controllers, or researchers on the ground. The robots are designed to complete tasks such as taking inventory, documenting experiments conducted by astronauts with our built-in cameras, or working together to move cargo throughout the station. In addition, the system serves as a research platform that can be outfitted and programmed to carry out experiments in microgravity, which will be helping us to learn more about how robotics can benefit astronauts in space. And with that being said, it's time to end our video. What do you think about these robots? Let us know in the comments. Like this video and make sure to subscribe to the channel for more amazing videos like this. We'll see you in the next video.